Hello my dear students, welcome back to my class of organic chemistry. In the last class we are discussing about the preparation of alkyl halide. So in the last class we have discussed about how to prepare alkyl halides from alcohol. So in continuation to this, today we will discuss the next methods of preparation, that is second method is preparation of alkyl halide from hydrocarbon. Preparation of alkyl halide from hydrocarbon. So under this, your first method is by halogenation of, that is hydrocarbon, by halogenation, free radical halogenation. Free radical halogenation. So in free radical halogenation, what we do, suppose we take an alkane. Suppose this is your alkane molecule butane. We react it with a suitable halogen, just for example Cl2, in presence of light, sunlight, that is H nu. Then in presence of, that is sunlight, what happens? The halogenation, that is free radical halogenation, takes place. In this case what happens? We get a mixture of alkyl halide. For example, now you see Cl, that is halogen, will replace one hydrogen from your butane. So we may get, if one of the hydrogen from this CH3 molecule is replaced by Cl, we get CH2Cl and HCl is released. Also we may get another product, that is if one hydrogen from this carbon or this carbon is replaced by Cl, then we get what? CH3, CH2, and one hydrogen from here is replaced by Cl. So we get a Cl here and CH3. That is hydrogen, one hydrogen from here is replaced by Cl and we get CH3. So we get a mixture of alkyl halides and the separation is tough in this case. So this method is not very applicable. Okay. Next method is by electrophilic substitution reaction. By electrophilic next method is by electrophilic substitution reaction. So by electrophilic substitution we may prepare aryl chloride or aryl bromide. For example, suppose this is your toluene molecule. Now if we react it with Cl2, in presence of either iron or iron chloride, FeCl3, as catalyst, then what happens? One chlorine, that is chloride ion from this Cl2 molecule, replaces one hydrogen from either from ortho position or from para position to give you That is, if one hydrogen from ortho position is replaced by chlorine, it gives ortho product, that is 2-chlorotoluene plus if one hydrogen from para position is replaced by chloride ion, then we get the para-chlorotoluene or 4-chlorotoluene. So we get a mixture of aryl halide, that is chloroproduct of toluene. Okay. Now you see, this is your orthochlorotoluene and this is para-chlorotoluene. Now, since the melting point of these two products are different, there is a large difference between the melting point, so we can easily separate these two products. In this way, by electrophilic substitution, we can also get, that is your aryl halide. Why it is called electrophilic substitution? Because this Cl2, when it breaks, so in presence of FeCl3, FeCl3 takes one Cl negative from here and forms FeCl4 negative. Remaining Cl positive, that is called electrophile, chloronium ion. This Cl positive replaces H positive from here. So this Cl positive acts as an electrophile and this electrophile replaces your H positive, so it is called electrophilic substitution reaction. Hope it is clear, and it takes place in presence of a catalyst. This catalyst may be either pure Fe or FeCl3. Hope this method preparation is clear. Next we will see the next methods of preparation. Third, see, that is called Sandmeyer's reaction. Sandmeyer's reaction. So by this Sandmeyer's reaction, we can also prepare your aryl halide. What happens in Sandmeyer's reaction? A primary aromatic amine is treated with, that is primary aromatic amine in present in an acid, that is HCl or HBr. When it is reacted with sodium nitrite, then we get the diazonium salt of that product, that compound. For example, so this is a primary amine, that is called aniline. The name is aniline. Now, when aniline is present in suppose HCl and we treat it with sodium nitrite, Na2 plus HCl, means this original aniline primary amine is present in your this acid and it reacts with sodium nitrite. So what happens? First it forms a diazonium salt of this one. That means diazonium salt means this NH2, in place of NH2 what comes? It becomes N2Cl. N2 is having positive and Cl is having negative charge. This is called diazonium salt of this compound aniline. Is it clear? So this is the first step, that is formation of diazonium salt of that compound. Next what happens? This diazonium salt of aniline or primary amine N2 positive, Cl negative reacts with cuprous chloride Cu2Cl2, that is called cuprous chloride. When this diazonium salt of this primary amine is reacted with cuprous chloride, then one of the chloride from here ion replaces this diazonium group and forms aromatic halide. That means this N2Cl is replaced by one Cl comes here from Cu to Cl with the release of pure nitrogen N2 from here, and twice CuCl is removed as side product. So by this we can prepare the chlorobenzene or aryl halide. Is it clear? So this method is called Sandmeyer's reaction. Hope it is clear to everyone. Now you see, since we have prepared the chloro compound, means here halogen is chlorine, so this is a chloro compound. So for this we had to take cuprous chloride. But if you want to get the iodo product, then we don't need to react this one with cuprous chloride. We can directly treat with potassium iodide. Next we can prepare also from alkene. From alkene also we may get the alkyl halide. For example, just say example it is. Suppose this is your ethene molecule. Now, if you treat an alkene with we may treat with hydrogen chloride, hydrogen bromide. Okay. So what happens when HCl dissociate? It forms H positive and Cl negative. So what happens? Electron from this pi bond breaks and goes to this carbon. It acquires negative charge and it acquires positive charge. So on the negative charge, this H positive will attack, and on the positive side Cl negative will attack. So we will get alkyl halide CH3 CH2 Cl. So by this method also we can prepare haloalkane from alkene also. Next you see, suppose there is an alkene propene. Suppose there is an alkene propene molecule. So this is unsymmetrical. Unsymmetrical means there is no plane of symmetry. That means odd number of carbon atoms are there. So we cannot get a perfect plane which can divide this molecule. So it is unsymmetrical alkene. So when an unsymmetrical alkene reacts with, suppose HBr, this is also unsymmetrical. So what happens? It leads to the formation of two different products. How? You see, CH3 CH. Now from this double bond, if this carbon acquires positive charge and this carbon acquires negative charge, so obviously Br negative part will attack here and positive part will attack here. That is, either that means it acquired positive charge and Br negative attacked here. It acquires negative charge, that is by electron is withdrawn to this carbon. It acquired negative charge and positive H attract here. This is the first case, first product. And another product is just the opposite. If the carbon goes to this, electron goes to this carbon, it requires negative charge, so it will attract H positive ion, and it acquired positive charge, so Br negative will attack here. So we get that means H positive goes to this carbon, it becomes CH3, and Br negative goes to this one, so CH-Br. So we obtain two different products. It is your primary compound, this is primary alkyl halide, and this is your secondary alkyl halide. Now you see, among these, one is formed in major quantity and another is in minor quantity. So this one is formed in major quantity and this one is in minor quantity, and this is in accordance to Markovnikov's rule. We will discuss this in later. So, or you may say, what is Markovnikov's rule? Markovnikov's rule says, in case of addition of, that is HBr or HCl to an unsymmetrical alkene, negative part goes to that carbon which leads to the formation of more substituted compound. That means that carbon which is more substituted, you see, suppose this is an CH2 double bond CH2, this one, and one hydrogen is substituted by CH3. So this carbon is more substituted, and if the negative part goes to that carbon which is more substituted, that is more substituted product is formed, and this is in major quantity. So this is Markovnikov's rule. More details you will get in the next chapter. So this way we can also prepare alkyl halide. Now this is all about, that is preparation of haloalkane, and next is one more method, that is all this we have discussed, that is from hydrocarbon, and next third is by halogen exchange. By halogen exchange we can also prepare alkyl halide. Okay, how? We'll see. Suppose methyl bromide, we have taken methyl bromide alkyl halide, and now if you treat with sodium iodide, so you see in this case there is an halogen group is there, iodide, and this is also an alkyl halide having bromine, that is BRS halide. So there is an exchange of halogen. What happens? This Na becomes Na positive and I negative. When it dissociates, it forms Na positive and I negative. Similarly, this bromine is more electronegative, so it withdraws electron, it forms bromide and CH3 positive. This CH3 positive takes I negative and forms CH3I, and the Br negative reacts with Na positive to give NaBr. So by this also we can prepare alkyl halide. So this is all about different methods of preparation of alkyl halides. And you see, this reaction occurs in presence of dry acetone. Dry acetone. This is taken because the alkyl halide, sodium bromide that is formed is get precipitated on dry acetone. For this it is used, and this reaction is called Finkelstein reaction. So this reaction is called Finkelstein reaction. We can, if you want to prepare fluoro compound, means alkyl fluoride, then what we have to do, suppose we take the initial product, this one methyl bromide, we have to get it reacted with what? Silver fluoride. If you treat this alkyl halide methyl bromide with silver fluoride, then what happens? This silver fluoride dissociates to form Ag positive and F negative. And similarly, just like previous case, this Br negative is released and this Br is taken by Ag to form AgBr as byproduct, and CH3 positive takes the reactive fluoride ion to form methyl fluoride. So by this way we can prepare the methyl fluoride. Okay, so hope these methods of preparation of alkyl halide or aryl halide is clear to everyone. Okay, in the next class we'll discuss about the physical properties as well as the chemical properties of haloalkane and haloarene. Thank you. Have a nice day.